Welcome back, and we'll be discussing about the practice assignment of week 1. So the first question is, we have two sequences, right? So depending upon these sequences, they have given three statements. Okay, let's see what each statement is. If an and bn both converge to some non-zero real number, then an and bn also converges to some non-zero real numbers. Yes, we know that. Second one, an and bn may converge even if neither an or bn converge. So for this, let's take an example. Okay, let's say an is something like this: 0 comma 1 comma 0 comma 1 comma, and then goes on repeating, right? So I'll take bn as 1 comma 0 comma 1 comma 0 and so on. So what will be an into bn? An into bn will be what? It will be 0, right? So yes, so this is converging to 0, but neither an and bn is converging, right? So these are oscillating, right? So this is also true. So what about the third one? A constant sequence, that is ai is equal to 0, is c for some real c. For all I belongs to n is always convergent, and it always converges to 0. Yes, so let's say if an is equal to, let's say 5 comma 5 comma 5 and so on, even if the n is infinity, right? So we'll always get the answer as 5. So it is converging to 5. This statement is also true. So the first one, so all the given statements are true. So moving on to the next question, match the following, right? So what do we have here? Here we have some equations, some polynomial functions, and in the second column we have they are asking us to find the degree of each polynomial, and the third one we have to identify the graph for each. Okay, let's say for the first one we have the degree of the first polynomial is what? The first one, it is matching with, we have 2 plus we have another x square here, and it is multiplied with the x square, x to the power of 4 plus 2, and we have another x square here. So the degree will be equal to 6. So the polynomial of degree 6 is here. So that is option D. And the graph for this. Okay, so the degree of a polynomial is even, right? So if this is an even degree, the graph will be in the positive direction, that is positive y direction. So check for all the positive y directions here. We have 1, we have 2, we have only 2 graphs. So here it has what? Only one time the direction of the graph is changing here 2 times, right? So here the direction of the graph is changing 1, 2, 3 and 4. Let's say we have a quadratic equation. For quadratic equation, the graph is something like this. Yes, so it is decreasing and increasing, right? So for if the degree goes on increasing, this parabola will be moving something like this. Okay, so for the polynomial of degree 6, number 3 is the answer. Okay, so for the second one, we have the degree as 1, 2 and 3. 1 plus 2 plus 3 is 1 plus 1 plus 1 is 3. So here we have the polynomial of degree 3. Here 2 is matching with a, and that is equal to what? This one. So this is the graph for x cube, right? So that is 1. What about the next one? Next one we have x, that is 1 degree 1 plus 2 plus again 2. Here we have another x square, that is 2 plus 2 4, 4 plus 1 5. We have polynomial of degree 5. Third one is matching with c, and that is equal to, what about even? What about odd? Let's say take the x cube for example. We have in the negative x direction, the graph is also in going downwards, right? It is also going to the negative side. Here also we have same thing. So for polynomial of degree 5, we have to find a graph such that it is moving through something like this, which also changes direction intermediate. So this is the graph. So number 4. What about the fourth one? We have 2 plus 2, that is degree 4. Degree 4 is remaining one, B, and that is matching with number 2. Okay. Right. So they have asked us to find out whether, sorry, they have given that an is equal to n divided by n factorial to the power of 1 by n. That converges to what? That converges to e. So this is the question given, and they have asked us to find out all the different options which are right. So okay, let's see for the first one. What about n? Or n is what? N is 1, 2, 3, etc. Right? So what about 3n? 3n, is this a subset of n? We'll find out. Let's say if I substitute n as 1, 2, 3, etc., I'll have 3, 6, 9, 12, etc. So I can say that 3n is a subset of n. So if this is the case, an converges to e. What about a3n? A3n should also converge to what? It also should converge to e itself, right? Because this is a subset of n. So this has to converge to e. So that is the rule that we have studied. What about the first option? First option we have a3n, right? It is not, they're telling us it is converging to 3n, 3e. So this is wrong. What about the second one? What about 2n? 2n is equal to what? 2, 4, 6, 8, etc. Is this a subset of n? Yes. So 2n is also a subset of n. So what should be a2n? A2n should also converge to e, but they have given it as wrong. Again, the third option is a repetition of the second option, so we have that. So what about option D? Option D, we have 2n plus 1 instead of n, right? N is replaced with 2n plus 1. So what about 2n plus 1? 2n plus 1 is equal to what? If I substitute n as 1, 2, 3, etc., I'll have I'll have 3, 5, 7, 9, 11, etc. All the odd numbers, right? Even this is also a subset of what? It is also a subset of n. So this should converge. A of 2n plus 1 should converge to what? It should also converge to e. Yes, so they have given it as like that. So option D is right. What about last option? Last option we have, I'm sorry, there is a typo. There is also a lan here. I'll write it here. Limit n tends to infinity lan of 3n divided by 3n factorial to the power of 1 by 3n. So this is the question, is equal to what? They are saying that it will be equal to 1. Let's say I have limit n tends to infinity lan of, I have a series a 3n, right? So what will be this a3n? A3n will converge to what? A3n will be converging to e. So I can substitute lan of e, right? So what is lan of e? Lan of e is 1. So this option is also right. Moving on. Question 4. For question 4, that the graph of some function is drawn below, choose the set of correct statements about it. So what is given? Limit of the function as x tends to 0 is 1. So I have x tending to 0 from the right hand side as well as from the left hand side. Even in the both cases, the graph is converging to what? The graph is converging to 0 itself. So first option is wrong. The second option is right. The limit of the function as x tends to 0 is 0. Limit of the function as x tends to 0 is unidentified. No. So this is also wrong. What about the next option? There is a unique tangent at the point x equal to pi, but not at x equal to minus pi. Okay, let's see what is there at pi. At pi, I can draw a tangent, right? X-axis will be equal to the tangent. The exaggerated figure would be something like this. This would be the direction of the graph, and this would be the direction of the tangent. right? So I can draw a unique tangent at x equal to pi. So what about at x equal to minus pi? Again at x equal to minus pi, if I increase the x direction, something like this. If I decrease the x value, the graph direction would be something like this, right? What will be the direction of the tangent? The tangent will also can be drawn somewhere around here. This will be the direction of the negative x, right? So there is a unique tangent at x equal to pi as well as in x equal to minus pi. Option E is right. They've asked us to find out whether the function is increasing or decreasing in x equal in the interval minus pi by 2 to 0. In minus pi by 2 to 0. So what is happening to the function? The function is monotonically decreasing, right? So this is the right option. So moving on. Depending on the graphs given below, predict which do not have a unique tangent at the origin. Alright. So we have to choose the graph which does not have a unique tangent. So what is happening here? So here so a tangent can be drawn to a graph at a point if there exists limit over there, correct? So if I move from the left hand side as well as from the right hand side, it is converging to a point, right? So at a point, a unique tangent cannot be drawn, right? A tangent can be drawn at any given direction, but a unique tangent cannot be drawn, something like this. But if I had a smooth curve instead of a point over there, if I had something like this, yes, then a unique tangent could have been drawn, as in the previous case. But here, since it has a point converging to a point, so unique tangent cannot be drawn at the origin. So first option is right. So what about second one? Second one, we have a smooth curve over at the origin. So yes, unique tangent can be drawn. What about the third option? Third option is again there is a point converging to a point at the origin. This we cannot draw a tangent over here. And what about here? Here the function is not even continuous at O, at the origin. So there is no graph at the origin, so we cannot draw tangent for a curve which does not even move at the origin, right? So even this is a right answer. So, and then moving on. We consider the following sequences: an is equal to 1 by n square, bn is equal to 0, and cn is 1 minus 1 by n. How many among these three sequences are the subsequences of the sequence 1 by n? So what is 1 by n? 1 by n is nothing but if n is equal to what? N is equal to, let's say, 1, 2, 3, etc. What is 1 by n? 1 by n is equal to 1, comma 1 by 2, 1 by 3, 1 by 4, etc. So what is the first option? First option is 1 by n square. That is, if I substitute n, I'll have 1 comma 1 by 4, 1 by 9, 1 by 16, all the square numbers. So does all these terms appear in 1 by n? Yes, so yes, so I can say that an is a subset of, what is this, 1 by n, right? Okay, so what about the second option? Second option, bn is 0 comma 0 comma 0. It is a constant series, right? So this is not a subset of 1 by n. So what about third one? Cn is equal to 1 minus 1 by n. If I substitute the values for n, I'll have 0 comma, if I substitute 2, I'll have 1 by 2 comma 2 by 3 comma 3 by 4 comma and so on. So does these fractions appear in 1 by n? No, even Cn is not a subset of this one. So how many among these three subsequences are the subsequence? Only an is the subsequence, right? So the answer is 1. Next question. Okay, consider the sequence an. an is given by an is equal to n to the power of 1 by n, which is known to converge to 1. So they have given as n to the power 1 by n converges to 1. What will be the limit of the sequence bn given by uh, n to the power of 2n plus 2n to the power of 1 by n minus 1. So I can write this as bn is equal to n to the power of 1 by n whole square plus 2 into n to the power of 1 by n minus 1, right? So what will happen to n to the power of 1 by n? This converges to 1 and this also converges to 1. So I'll have 1 plus 2 into 1 minus 1. So the answer is 2. Next question. Okay, suppose there are 3 schemes available for renting a studio room given in the table below. We have 3 different equations. So this is the floor function and this is the ceiling function, right? So sorry, yeah, so this gives us all the largest integer less than or equal to, and this gives the smallest integer greater than or equal to, right? For example, if t is, let's say, 5.3, let's say, so this gives the value as 5 and this gives the value as 6, right? So moving on, what is the question? If Rana wants to book a studio for 2.6 hours, which scheme should he choose to avail this studio in the minimum cost? Okay, so I don't know why there is a repetition of this typo. I'm sorry for that. Okay. Okay, so I'll have to substitute t is equal to 2.6 for all of this. So what I'll have is p1 of 2.6 is equal to 1 of 2.6 is equal to 100 of floor function of 2.6 plus 200. 100, 2.6, the largest smaller integer is what? It is 2 plus 200, so that is equal to 400. So for the second scheme, P2 of 2.6, so I have 100 into ceiling function of 2.6 plus 200. So this is nothing but 100 into 3 plus 200, that is nothing but 500. So what about the next scheme, P3 of 2.6, that is equal to 100 into 2.6 plus 200, that is equal to 260 plus 200, that is equal to 460. So let us see the options now. For 2.6 hours, cost of scheme A and scheme C are the same, so this is wrong. For 2.6 hours, cost for scheme A is minimum, yes. So what about other options? B scheme is minimum, no. We have scheme B and scheme C are the same, no. Cost of C is minimum, so this is also wrong. Option B is the right one. Okay. Next question. Okay, they have given us 2 figures, so we have to identify which scheme has the graph given here, right? So we have a floor function in the scheme A and we have a ceiling function in scheme B. So which of this is floor function, right? Floor function is the one which always gives us less than or equal to, right? Let's say you have 0.5 as the term. We'll have the value as 0 we have here, and if I have somewhere x as here, I'll get the value as somewhere here. So this is the graph for scheme A and this is the scheme for graph B, right? So first option is the right one. Okay, so the tangent to the function p1 of t which represents scheme A does not exist at 1. So this is right. So we know that for any we know that for a floor function, tangent cannot be drawn at all the integer points, right? Because because at integer points limit does not exist. Okay, what about the second option? Tangent to the function p1 of t which represents scheme A does not exist at A for any natural number. Yes, this is also true. I just said that. The tangent to the function p3 of t which represents scheme C does not exist at 1. So what is p3? p3 is a linear function, right? So linear function is nothing but a straight line. So straight line is continuous at all points, so we can draw tangents at all points, right? So this is wrong. What about the last option? Tangent to the function p2 of t which represents scheme B does not exist at A at any natural number A. Yes, even for this case we will be having graphs something like this at, let's say this is an any natural number n, so the left hand limit and the right hand limit will not be equal, therefore the graph is not continuous at n, so therefore we cannot draw a tangent at all the n.